Hey guys, Ben Pearson, the Roaster Track here, and we're gonna try something a little bit different here. I was talking to some people when I was at the US Space and Rocket Center. I'm a docent there yesterday, talking about global warming and talking about how we could not possibly have done the emissions that could have changed the global climate. And so we're gonna do a little bit of math here to figure some stuff out. So I have three things here. I have a calculator, and I have a notepad, and I have Google, and I have not done any of this. This is all going to be effectively live. I'm not live streaming this, but other than that, it's effectively live. So there's 3 points that are pretty much undisputable with global warming. Carbon is a greenhouse gas. Second one is that carbon dioxide levels are rising. And the third one is that the Earth's average temperature is rising. Those are pretty much undisputed. The last one is the hardest one. Carbon dioxide levels are rising, very easy, and carbon is a greenhouse gas is pretty straightforward. Little basic chemistry is all it takes to do that. Along with these, there's kind of 3 areas that are a little bit harder, but there are often questions that are brought up. So the questions: 1, where is the CO2 coming from? Second one is what will the impact be from the rising CO2? And there was a third one that I was thinking, but what will be the impact? And third is, does the increase of CO2 match predictions? Match the increase in temperature. So these are the 3 questions. Now, of these, this first one is something we can actually try to answer here, because the statement that is made very publicly is that carbon dioxide levels are coming from the burning of greenhouse gases. So this one, what will be the impact? That's really, really difficult to know. This takes huge simulations to do. Does the increase of CO2 match the increase of temperature? This one's a little bit more straightforward and something that I could try to do. If you guys are interested in that, then let me know. I'm not going to be able to make much of a quantitative analysis of this one, the second one, but there are some things that we can try to do. So the hypothesis that we're going to put forward is that CO2 comes from burning fossil fuels. Okay, so how would we go about determining if that's the case? Well, we know that carbon dioxide levels are rising. And since this is straightforward enough to be able to tell fairly easily, let's just pull up Google here and say carbon dioxide levels for in atmosphere for last 200 years. Let's just see what this says. So it says that they range from 170 to 300 parts per million. And so then we are now more than 400 parts per million. Okay. So let's take a look at this plot. This is thousands of years ago. So 300 points per million seems to be about the highest that it's been for the last million years. And this is from ice core samples. I have no reason to doubt that those are true and accurate statements. We do notice that it had been kind of on an upward trend even before this. So let's say 300 parts per million is where it was. Parts per million. and 400 parts per million is where it is today. This is pre-industry. 400 parts per million is where it is today. Okay. So the last thing we need to know is, are the parts per million, is that by mass? Mass or volume? Not going to trust any of these numbers here, but I'm just trying to understand what this ppm means. I don't know. We're going to assume that it means mass, but that could be wrong. So the two possibilities are mass or volume. So we're going to assume mass. Let me actually make this a little bit bigger too. So that means that there is about 100 parts per million increase in CO2 by mass in the last 150 to 200 years. Okay. And it's probably a little bit more than that because the 400 was from a fair bit earlier, but let's just go with this for now. So 100 parts per million, how much does the atmosphere weigh? Well, that seems like an insurmountable question, but we actually have the knowledge to estimate this right off from the get-go. We know the pressure that we feel, which is about 14 pounds per square inch, and I don't know what the units are in newtons and whatnot, is effectively the amount of air that is over there. So for every square inch of Earth, then there is 14 pounds of atmosphere that is directly above it. It's pretty convenient to do, and it works actually quite well. So how does that come out to be? Well, let's do let's say atmospheric pressure in newtons. So I think Pascal is so it's 100,000 parcels, which is 1 Newton per meter squared. So we know that whatever the Earth is, so 100 newtons per square meter is how much the atmosphere weighs. And then to convert that to kilograms, we're going to effectively, we'll divide by 9.8 just to make the math easier. We're going to call it 10 tons per square meter. Just to make the math a little easier. We're just trying to understand if this is in the right ballpark. So 100 parts per million, well, okay, let's go back to the Earth's. The Earth has a diameter of, call it 6,700 kilometers. So we're going to times by 6,700. So the volume is 4 pi r squared. So we actually need to times it by a million to get the units right. So this is how many meters times 4 times 3.1415. That's a very, very big number. So I'm just going to put this down. The atmosphere is weight of atmosphere is billion, about 564 trillion. Hang on. This is meters squared. So 564 trillion meters squared. And then for every meter squared, there's 10 tons. So we're going to say it's 5.7 quadrillion tons is roughly what the weight of the atmosphere is. Okay, so we've increased by 100 parts per million. So that's going to take that to be 570. Let's see. Five, 6, 4, oh, da da da. Something like that. And then what we're gonna do is get rid of 2, 3, 4 digits. So what number does this come out to be? So this is 564 billion tons. That's how much carbon dioxide approximately has been released into the atmosphere in the last 200 years, based off of the ice core sampling that we've done and the current measurements. And we've been making, accurate measurements of the carbon dioxide in the atmosphere of Earth for quite a while. It's pretty straightforward to do. Okay, so now let's start to get into the math. This is how much we're looking for, tons of CO2. We want to see if the math will give anything remotely close to that. So how much oil burned per day in the world? So this is pretty straightforward. Okay, let's go with this. There is 35 billion barrels of oil burned per year. 35 billion barrels of oil burned per year. Okay. How much does what's the mass of a barrel? So mass of barrel of oil. It's about 300 pounds or 136 kilograms. So 136 kilograms per barrel. Now, how much carbon dioxide comes from that is a little bit tricky. So most, oil is hydrocarbons. So you're going to have something like C4H10 or something like that. And all of the H is going to be released as oxygen. And all of the carbon is going to be combined. So it's one carbon, 2 oxygen. So really, when you're burning coal, the carbon and the oxygen weighs about the same. You really expect there to be about 3 times the amount of carbon dioxide. So in this case, when this is burned, this will be CO2 times 4 plus H2O times 5 is what the mass you're going to plus some O2 that's just in the atmosphere. And so the mass of this will be about 3 times what this is. So you could say for every kilogram of oil that is burned, then about 3 times as much will be released. So we've got 35 billion times 136 times 3. And that comes out to be what? So let's go to our calculator. So 35 billion times 136 times 3 is 14 trillion. 14, we'll just call it 14 trillion tons of CO2 per year. Just from burning oil. This doesn't count coal or anything else. Okay. So is this tons though? This is not tons, this is kilograms. So 14 billion tons. Because you divide by 1,000 to get to tons. Okay. Well, let's take 564 divided by 14 billion. 564 divided by, try this again, 564 564 divided by 14 is 40. So in 40 years of burning this amount of oil, it will create the amount of CO2 that we see that has been emitted in the atmosphere. I did not expect it to be that clear cut. I expected we were going to have to look up the coal. Now, granted, not all oil is made into gasoline and burned. You know, some of it goes into things like plastic. But in 40 years, there's enough carbon dioxide that is burned from potentially from oil to match the amount of carbon dioxide that we have seen. And so this is pretty indisputable. I mean, I looked this up from public numbers and it all comes clear, and this doesn't even take into account the coal. So this is telling me that there's carbon dioxide that's actually hiding, which is, I believe, what they say is being seen. They see that carbon dioxide is, you know, going into the ocean. The oceans are becoming more acidic as a result of this carbon dioxide because we're actually producing more and nature is starting to absorb some of it. Huh. Anyways, you guys can go ahead and do your own stuff. And like I said, you know, looking at these questions, this question is something, this is all in your abilities to do, to prove stuff like this out. You know, the impact is, this is taking complex weather models to be able to make this work. And the CO2, it may be a stretch. I think it's in my abilities, but it will be a little bit of a stretch. If you guys want me to try it, I'll try something like that. But thank you guys so much for joining me. Let me know whatever questions or comments you guys have. And thanks for checking this out. Until next time, keep on tracking. Take care. We will see you then.